Hi, Professor LaShan again, and I am going to finish the test 3 review from Math 107 from the Chapter 10 stuff, starting with problem number 11. So it says the number of hours 9 students spent studying for a test and their scores on that test are given in the following table. So which is the independent variable X and which is the dependent variable Y? So the way the problem is worded, the number of hours spent studying on the test and then their scores on that test means that the hours spent studying should have an effect on the test score. The test score should be dependent on the hours spent studying. So the X would be hours spent studying and the Y would be the test score. So then using the data provided, draw a scatter plot. So I have C graph here and I didn't want to take all the time to redraw it. This is already in the answer key here. So if we take, so X is the hours spent studying, which went from 0 to 8. So that's my X here, and I labeled hours spent studying. Y is the test score, which went as low as 40 to as high as 95. So I just counted by 5s on the Y-axis, and I labeled, and I also put a, I should put a title on this graph. Test score versus hours spent studying. And so I just plotted these points here. There were 9 points, 0, 40, 251, 464, and so on. So 0, 40, 251, right, 2 up 51, 4, 64, right, 4 up 64, 5, 69, 5, 73, and 5, 75. Then we had 6, 93, right, 6 up 93, 7, 90, right, 7 up 90, and 8, 95, right, 8 up 95. So we've got our scatter plot here of those 9 values, okay, looking at this. And we can look at this and we can see that it looks like there's a positive linear, falls fairly close along a straight line, linear correlation, fairly strong, positive. As number of hours increases, test score increases, which makes sense, right? So it said in question C, does the data suggest a linear relationship? If so, what kind? And as we said, it looked like it was a positive linear relationship going up to the right. And so our next question, D, says calculate R. So remember, this is where we go to the line of best fit tool that we talked about in class. And we put in these values, and I'm not going to spend all the time going through that. You all can do that. And if you put in these values, these 9 points, and look at the line of best fit tool and ask it to calculate it, you're going to find that R turns out to be 0.97. So yes, it's a very strong positive linear relationship, close to +1. Okay? That's from the line of best fit tool. So now we want to test the significance of the R found in part D using alpha level significance 0.05. So actually, Alex generally does it with the critical value table. So that's how I'm going to do it. There are 2 other methods, but that's how Alex does it. And so we have our null hypothesis that rho, the population correlation coefficient is 0, meaning there's no correlation between X and Y. And the alternative is that the population correlation coefficient rho is not equal to 0. Remember the sample size was 9. That makes the degrees of freedom. For this case, the degrees of freedom are n-2 because we're working with 2 variables. So the degrees of freedom are 7. The level of significance is 0.05. So we're going to go to this critical value table, table I here, with 7 degrees of freedom. Level of significance 0.05 gives us this critical value here of 0.666 that we're going to compare our R value to see whether or not it's significant. And if our R value is significant, then we can go further and do the regression equation and do linear regression. And so because this is a 2-tailed test, we can talk about the critical value being 0.666 or plus or minus 0.666. And then we're going to compare our R that we just calculated, the sample correlation coefficient, to that critical value. Since it's positive R, we'll just compare it to the positive one. And if R is greater than that critical value in terms of its absolute value when it's positive, it's closer to +1 than this critical value, it is, then it's significant. And we know that then we can reject the null hypothesis and know that there is a significant relationship between X and Y, which is hours spent studying and the resulting test score, which we could really see from the graph that there's a significant linear relationship. We can see from the measurement of our sample correlation coefficient, but this tells us that it's significant. So then that means we can go further and keep going and do our linear correlation that it's significant. We're going to find the equation for the regression line of best fit. Again, that's in your line of best fit tool, that the website. So you already have that when you put in the R to calculate the R and you put in these 9 points, and it gave you Y equals, but we're going to call it Y prime. The predicted value of Y is 37.45 plus 7.45x. Again, coming from that tool that I gave you to use, the line of best fit tool. And so now we're going to use that information to answer questions 11G and 11H. So 11G says, use the regression line equation to predict the expected test score for 3 hours studying and 10 hours studying. Okay, so remember, we can only use the regression line for the interval of values that X is observed here. And we know that we have from 0 to 8 hours studying. So calculating for 3 hours spent studying, that's fine, we can do that. But 10 hours spent studying, that falls out of our outside of the observed X values interval. So we really can't use the regression line equation for 10 hours spent studying. We just can't, because it falls out of the 0 to 8 interval for our observed values of X. But we can do for 3. So if we go back here we go. So if we go to our regression line equation, predicted Y equals 37.45 plus 7.45 times X. We're using X as 3. So putting that in, multiplying, and then adding, we find that if someone spends 3 hours studying, they can expect to get about 59.8, about 60 on the test if they spend 3 hours studying. Again, for 10 hours spent studying, we cannot predict a value for Y because that X value is outside of the observed X values that were given in the sample from 0 to 8. So the regression line is, we cannot use that to predict. Okay, so the last question here was, what does the slope tell you about the test score? What is the meaning of the Y prime intercept, the predicted Y intercept? So if we go back to this equation here, let me write it down again so we have it. Remember, it was Y prime equals 37.45 plus 7.45x. So our slope is 7.45. Y equals mx plus b. Here's the m. Ours calls it Y equals a plus bx. So the b for us is the slope, and the slope here was 7.45. That's b, or what we would call m in algebra. And so that tells us that for every additional hour spent studying X, that the score improves by a margin of 7.45 points, 7.45 points. So every additional hour spent studying improves the test score by about 7.45 points. That's what the slope tells us, the relationship of Y and X. Then the Y predicted intercept, which is the A value here, at 37.45. Remember, at a Y intercept, X is always 0 at the Y intercept. So that says a student who studies 0 hours can expect to earn this score, 37.45 on the test. And if we looked at our observed values that they gave us, which came from the sample, a student who studied 0 hours got about a 40 on the test. Okay. Now, if you look at, by the way, I should go back here. If I were to plot this line of best fit here on this plane here, if we were to plot the line of best fit, and you do X is 0, you know, with the line of best fit, the Y should be about 37.45. And if you do X is 3, the line of best fit is somewhere around here. And what did we get for the line? What did we get? Let me go back. We got 59.8. So this is showing you that when X is 3, and if I plotted the line of best fit, it's probably right around here, that with a predicted value for Y would be about 60. So if we were to put that line in here, those points should be on that line that we got from the predicted value of Y. So to finish here, I just want to look at number 12. Here we go, number 12. And I didn't write anything down here. I just want to walk through here. For each of these following, state the type of relationship and predict an R value, linear correlation coefficient sample if possible. So in 12A, this is not a linear relationship, so we cannot even use R, predict R, because, or calculate it because it's not linear. So R is not relevant here. For 12B, there is no linear correlation. So even if we put all of these points into our line of best fit tool, the R should turn out to be pretty close to 0 because there's no relationship. Now that's different than here because there is a relationship, it's just not linear, so we can't use R. Here, if there's no type of relationship between X and Y, then we can say the R value would be 0 or something very close to 0. In C, there's a pretty strong positive linear relationship between X and Y. Again, this is just predictive. We don't know the actual values. We can't calculate it. So I would say that in R, because it's a strong positive linear relationship, R is going to be at least 0.9 something. I think I put in the answer key 0.95. Again, it's just a ballpark figure. For D, there's a negative linear relationship. It's not really strong straight line. So maybe it's negative for the R value, negative 0.4, negative 0.5, something like that. It's not that strong, so it's not going to be that close to -1, but there is definitely a negative linear relationship. For E, for 12E, there's a positive linear relationship. It's certainly not as strong as 12C. So maybe the R value is 0.8, 0.85, something like that. Again, it's just predictive. It's somewhat strong, but it's not as strong as, for instance, 12C, which is probably 0.95 or something like that. For 12F, it's a perfect negative linear correlation. So the R value is -1 or -1.0. For 12G, it's a perfect positive linear correlation. It's a perfect straight line. And so we know our R value would be +1, 1.0. And then for H, it's a pretty strong negative linear correlation. So again, it's going to be fairly close to -1, clearly not as strong as this one in 12F. So, you know, I would say R is -0.9, something like that, ballpark figure. So there we go. That's number 11 and 12, which deals with chapter 10 on correlation and regression.